Hey guys, welcome back. It's been a little while since you've heard my voice. I figured I would give you some video notes here and teach you a couple things about triangles. So the two topics we're going to learn about today, by the way, we're in section 5.6.1 in your books. We're not using the books for today, but in case you wanted to look at some related content to get a couple extra problems, you can look in there. First thing we're talking about is called our triangle sum theorem, and then we'll talk about the exterior angle theorem. Triangle sum theorem you might not know by name, but you know it in practice. So let's talk about that first, triangle sum theorem. All this means is that all three interior angles of a triangle will always add to 180 degrees. So here's a triangle, call it triangle ABC. By the way, we use capital letters to name the angles. The measure of angle A plus the measure of angle B plus the measure of angle C is going to equal 180 degrees, and that's true of every single triangle you're ever going to come across. There's some proofs that you can watch. I won't get too much into it, but if you're curious, you can go on YouTube and just say triangle sum theorem proof, and you'll probably find a couple different ways that you can prove that. So we'll do several problems dealing with that. And let's do those first. Let me zoom in on these. So most basic, we'll do number one. So if I do x as my variable plus 58 degrees plus 47 degrees, I know that's got to equal 180. If I combine these, I get 105. And after I subtract 105, I get x is equal to 75 degrees. Okay, 3 is a little different. Now I don't have just x, I have an expression 3x minus 1. So this works the same way. This is a 90-degree angle because I have the right angle symbol. So I know that 90 plus 31 plus this expression 3x minus 1 has got to equal 180. So let's see, combining these, I get 120 plus 3x equals 180. Subtracting 120 gets me 3x equals 60, and I get x equals 20. Okay. All right, so let's come back over here. We'll take some notes on the exterior angle theorem. This one's a little tricky, a little trickier. All right, so let's draw that same triangle. So I have A, B, C. This time I'm going to give numbers to my angles. So let's say that this is angle 1, angle 2, angle 3. And then let's say you're given a figure where not only is it a triangle, but one of these three sides, let's say this bottom side, this side has been extended outside of the triangle. Okay, so my triangle is still the same. I still have angles 1, 2, 3 for my interior angles. But now this extended side and side BC create this angle outside. That's called an exterior angle. Okay, so that's an exterior angle. And we're going to call that angle 4. Now we can see that angle 3 and 4 form a linear pair, right? So angle 3 and angle 4 form a linear pair. We learned about that on Monday. So I know they are going to be supplementary, so the measure of angle 3 plus, this is just review, by the way, the measure of angle 4 is going to equal 180 degrees. So if I know one of them, I can figure out the other one. Okay, so that's not the relationship we're going to focus on in these notes. The angle that forms a linear pair, we're going to ignore for right now, but let's look at these other two angles, angle 1 and angle 2. When I'm talking about angle 4, angle 1 and 2 are considered remote interior angles. Okay, so angle 1 and angle 2 are remote interior angles, and it's always in relation to another angle. So they're remote interior to angle 4. They're the two angles inside that are not touching angle 4, right? Angle 3 and 4 are touching, so 1 and 2 are remote interior. So how do we remember that? Well, if you're sitting on the couch and you want to change the channel, you hit the remote, right? You're far away. So that's how we remember that they are remote interior angles. So this exterior angle theorem tells us that the measure of our exterior angle, in this case angle 4, is going to equal the sum of, that's supposed to be a sideways plus sign, let me redo that. It's going to equal the measure of angle 1 plus the measure of angle 2. Okay, and this might look different if the different angles are named differently, but in this specific example, this angle 4 is going to equal angle 1 plus angle 2. So let's go look at a few examples here. So if we look at 4, I have one side of my triangle has been extended, right? So that creates x, which is an exterior angle. These two angles inside, right, this 34-degree angle and the 21-degree angle, that might not be clear, that goes up in that top corner, are the two interior angles that are not touching. They do not form the linear pair with my exterior angle, right? Let's call this, I'm not going to name it, I'll just shade it with blue. That's the linear pair with x. So we're not going to use that one when we use this theorem. But the other two are the remote interior. So let me write that, remote interior angles. So 34 and 21. So I know that the measure of x has to equal the sum of those two remote interior angles. Right? So that gets me x is equal to 55 degrees. So that's pretty cool, right? There's other ways you could find x, but that's the quickest way. So this gets a little trickier. You know, sometimes the triangle looks different. So again, for number 5, here's my side that's been extended. So this is my exterior angle. Here's the angle that formed a linear pair. So that's not remote. But these two angles here are remote interior. So we'll do the same thing. We'll say, okay, this 100 degrees has to equal my first remote interior, 2x plus 3, plus my second remote interior, which is 51. Now I can combine some stuff. 100 equals 2x plus 54. Subtracting 54, I get 2x equals 46. And x equals 23. Okay, so x is 23. That's not the measure of this angle down here, right? This angle, I know we're not asking for this, but I might say find the measure, let's call this angle A down here, of angle A. If it were a little more involved problem, I would say, okay, I know x is 23, so the measure of angle A would have to be 2 times 23, right, because it's 2x, and then plus 3. So that gets me 46, 47, 48, 49 degrees. Okay, so this angle down here is 49 degrees, and that works out, right? 49 plus 51 gets me that 100 degrees. So sometimes we're going to ask you for the value of x. Sometimes I'm going to ask you for the entire angle measure. So just make sure once you solve for x, are you done, or am I asking you to go on and actually find the measure of the angle? All you gotta do is plug it in. Pretty cool problems that are a little more involved, but not too bad. Kind of drawing on some things that we did last week. So I'm sorry, on Monday. So find the measure of x on 13. Okay. Well, if you guys notice, I have two triangles. They kind of meet at this center point here. I need to find x. So both these will be the same. I guess I could find either one, but I don't know any information there. So I'm not ready to start in that triangle. I need to start in this triangle on the right. Okay. So I know two angles. Let me call this angle y, just because that's what I wanted to do. You can call it anything you want. Or let's say it's y degrees, right? It's a variable, it's y degrees. Well, I have a triangle here. A lot of us struggle to see a triangle when there's other stuff, but it's still just a triangle, so the same rules apply. I know that 53 plus, oh, not 53, 57 plus 43 plus y plus that angle, you can put a question mark in there, whatever it is, that has to equal 180 degrees, right? So let me start there, and then I can at least complete this triangle. So this gets me 100 plus y equals 180, and we know that y is equal to 80 degrees. Okay, so I'm going to come back, I'm going to erase this, that's why we use pencil, right? So this third measure is going to be 80 degrees. Well, if we look, I kind of have these two intersecting lines, right? And we learned about vertical angles on Monday. So if this measure is 80, we know that the angle diagonal from there right across, that also has to be 80, right? Just because there's triangles involved, you still have the vertical angle relationship when you have basically like an X like this, okay? The ones on opposite sides will always be vertical and therefore congruent. So those are both 80 degrees. And now that's going to help us. Now I like to say we jumped into the triangle of interest. So this is the one I want to know about. Well, I know x plus 80 is going to give me 180. I'm going to use that triangle sum theorem again. So 2x plus 80 equals 180. And we're going to get 2x is 100, x is equal to 50. Okay, so if I look at 14, let me clear up a couple things here. First, this angle here is 80 degrees. Okay, so I have like this lighter triangle. Well, the bottom side is bold, but this lighter triangle, then I have this right triangle over here that's in all black, and then I have like this smaller overlapped triangle. By the way, this is 90 down here, right? So I need to find this angle here. And the approach I'm going to take is like that's not an angle of the triangle on the left or the triangle on the right. It's created from overlapping and getting the smaller triangle. I want to find these two angles because this is a third triangle we're going to look at. And if I know these two, I can use my triangle sum to find this one up here. Okay, so that might seem a little confusing, but we'll go ahead and try it. Okay, so I know 50 and 80 is 130, so this angle down here is going to have to be 50 also. Okay, because I know that that triangle on the right has to add up to 180. Okay, so that's 50. This triangle on the left, the right triangle, 90 and 65, and this angle down here, okay, those have to add to 180, and that's going to give me 25 degrees. So what I've done is I've created this other triangle inside, right? This one here, and it's, I should have done that bigger. All right, here's kind of a blown up version of it. Here's X, here's 50, here's 25, and we can use our triangle sum theorem to get, let's see, 75 x is going to equal 105 degrees.